Hey everybody. When last we talked, we had introduced ourselves to this mathematical character I, which represented an imaginary unit. The unit's imaginary because it represents the square root of -1, which is something that is kind of impossible based on all the real numbers that we know, because we know that negatives can't multiply with themselves to make a negative number, and neither can positives, so this should be impossible. But we're still going to take advantage of it to try solving some problems that wouldn't have solutions otherwise. This is going to serve as some review for last week, while also giving us an opportunity to use this sort of unfamiliar I character. We solve equations the same way that we always have started, though. If I see something like 2x squared plus 9 equals 1, I'm going to begin by subtracting 9 from both sides. This will leave us with an equation 2x squared equals -8. And then, as always, we're going to divide away this coefficient of 2, creating x squared equals -4. This is where we can see that we're going to have an imaginary solution because no squared real number should make a negative value, but this one does. So as we did last week, we're going to take the square root of both sides. And now the square root of x squared leaves just an x behind, and x equals the square root of -4. Now there are a couple of nice things about our situation here. Oh, I forgot my plus or minus. Remember, every time that you take a square root of a number, to cancel out the squared, you need to have a plus or minus. At this point, a couple of nice things are going on for us. We're familiar already with the negative and how this turns into an I, and we know the square root of 4 is pleasant also. So the way that I would split this out is I would say that x is equal to plus or minus the square root of -1 times the square root of a regular 4. Right, I just pulled the negative out. And now we know that this square root of -1 is the same thing as I, while this square root of 4 is the same thing as 2. So our final answer here would be that x is equal to plus or minus 2i. Throw a box around it. Because it's plus or minus, it is 2 solutions, and those are the only 2 solutions to our problem. Let's go ahead and try that again with a little bit faster pace. 3x squared minus 5 equals -446. I might need to use a calculator here at some point, but we're going to begin by adding 5 to both sides. 3x squared is now equal to -441. We're going to need to divide by 3 next. Divide by 3. Oh gosh, what is this? This is going to be 147, I believe. X squared is equal to -147. And now, same as before, we're going to need to take the square root of both sides. So square root here, x is equal to plus or minus the square root of -147. Now this is a pretty ugly number right here, but if you have if you've done some practice trying to work with all of your nice squares, you know the ones we're looking for are 2 squared, which is 4, 3 squared is 9. We'll just keep making this list for a bit and see what goes in. Then 36 is 6 squared, and 49 is 7 squared. I recognize that 49 can fit into this -147, so that's how I'm going to split these values up. X is equal to plus or minus the square root of -1 times regular 147 can be achieved by doing the square root of 49 times the square root of 3, because this 49 right here goes into 147 3 times. Now we'll go ahead and pluck out our pieces. Here's our I. In green, we've got the square root of 49, which is 7. And then remember, it's okay to still have kind of an ugly child in our problem here. We've got the radical 3 going on. And now for our final answer, we just put them in order. Natural number, followed by I, followed by the square root of 3. Let me do that off to the side here. X equals plus or minus 7i rad 3. Okay, so using just a little bit of the different tools that we talked about last time, we know how to pull I out of a negative if we're taking the square root of that negative number. We also know just some regular solving equations skills. So once we have those, put them together, you can get your solutions. You'll have a plus or a minus, and probably have an I in your answers most of the time here. So let me go ahead and give one to you guys. I'm going to bring this to the front. This is your problem to solve. If you would, please go ahead and pause me while you try this one out, and then I will work through it in just a moment. Okay, hopefully you guys gave this a shot by yourself and have an answer. I'm going to motor through this as fast as I possibly can. So we need to subtract. 4x squared is equal to negative 26. Oh, excuse me, not 26, negative 24. 4x squared equals negative 24. We would have ran into some serious trouble if I had a 26 there. Divide by 4 is going to make this x squared equals negative 6. And negative 6 is going to be a nice number for us because none of our perfect squares go into it. We can't really pull much out of it. So x equals plus or minus the square root of negative 6. The only thing that we can pull out of this is we can separate the negative 1 from the 6. And that means that this square root of negative 1 can become I. So we've got an I here. We've got a radical 6 below. I'm just going to put my x equals plus or minus here underneath it and box that answer up. There you go. Check your work. Hopefully you guys arrived at this answer also. With that, we'll go ahead and move on to our last idea of today. I say last idea, but it does have 2 pages of stuff. But we're going to talk about the powers of I and how i's that get multiplied together end up interacting in some kind of interesting ways. All right? So we start with the idea that I to the first power is the square root of negative 1. Our entire premise is kind of built around this, right? So anytime you see just a regular I, you know that this is what it stands for. But this becomes really useful to us if we end up with something like I squared, because that's now the square root of negative 1 squared. Remember, squares and square roots cancel each other out, so that'll happen in this case too. And the I squared just becomes the value negative 1. Therefore, it's pretty convenient for us when i's end up multiplying together because it gets rid of our square roots altogether. If you look at something like I to the third, you can think about this as I squared times I to the first. And so we'll just look back and compare this to our previous 2 answers. All right, we know that I squared is negative 1. So this is negative 1 times, let's maybe not write it that way, equals negative 1 times I to the first, which is the square root of negative 1. All right, which means that this I to the third value is actually negative 1 times anything, just put the negative sign on it. Negative square root of negative 1. Okay, that's pretty weird, right? I cubed is probably the hardest of these to think about, all right, because you've got 2 negative signs, and yet these ones don't cancel out like they usually do. But this works out really nicely for us when we move on to I to the fourth, because we can now think of I to the fourth as I squared times I squared. And since both I squareds are negative 1, I to the fourth is the same as negative 1 times negative 1, which just becomes positive 1. Okay, so what's convenient for you are I squareds, because we know that these are just negative 1, and I to the fourth, because these are just positive 1. And you can see how we might use these when we look at some more complex problems, like what is I to the 5th or I to the 14th, and they really don't get any more complicated, because you could split apart this I to the 5th as I to the 4th times I to the 1st. You know that I to the 4th is the easiest that this gets, right? Because I to the 4th is the same thing as 1, and I to the 1st is just I, or the square root of negative 1. You could call this, I'm honestly not sure if I would rather have you call this answer the square root of negative 1, or just I. I think we would probably have you call this I if we were answering a question, right? But I to the 4th just cancels out because it's the same as multiplying something by 1, multiplying by I to the 4th. Along those same lines, we can do the same thing down here for I to the 14th. Yeah, I know this number's big, but look, if we have an I to the 4th, and then another I to the 4th, that's I to the 8th, times I to the 4th again is I to the 12th. We just need 2 more i's, so times I squared. And then remember just how this, like I to the fourth, turned into 1, so it was kind of like it canceled itself out and just left an I behind? Well, this is 1 times 1 times 1 times I squared, which we still have to deal with. Okay, and actually, instead of calling that I squared, I should know better than that. I squared is over here. I squared is negative 1. Put that in parentheses. So 1 times 1 times 1 times negative 1, I to the 14th is really the same as negative 1. Okay? No matter how big this exponent is, your I to the blank will always be one of these 4 values because it just kind of goes in a cycle. Negative square root of 1, negative 1, negative negative square root of 1, 1, and then as you can see, I to the 5th starts over at the square root of 1 again, and we just keep going over and over and over and over again. Right? Kind of cool. I don't expect that you'll see I to the 14th or something like that very often, but here's a situation where you might see some i's that are kind of like crossing streams a little bit. All right? So, multiplying with imaginary numbers. Remember that when you multiply these, just multiply the coefficients together first, very simple, and then count up all of your i's, and that's the exponent on them. So 4 times 7 is going to make 28. I times I makes I squared. And since we know, little note to ourselves, I squared is equal to negative 1, this is 28 times negative 1. So this simplifies to negative 28. Similar setup down here for our second example. Negative 4 times 2i times negative 9i. Well, negative 4 times 2 is negative 8, and negative 8 times negative 9 will make positive 72. And then I count up my i's. There's 1, 2. So this is I squared. Now remember, I squared is the nice convenient one for us because it's the same thing as negative 1. So this is 72 times negative 1, also known as negative 72. We can sometimes try to make these pretty tricky looking on you by doing something like this. Remember that something to the third power just means that it is multiplying with itself that many times. So you can think about this 2i as 2i times 2i times 2i, right? Now you could write those all out, or you could just jump to like whatever multiplying them together makes. 2 times 2 times 2 is 8. And if we count up the i's, there's 1, 2, 3 of them, so we have 8i cubed here, times 5i. Multiplying through this, 8 times 5 makes 40. I to the third times I to the first, we just make that 4 i's multiplying together now, so that's I to the fourth. And then you'll recall from our last slide that I to the fourth is just 1, which makes our life very easy. So this is equal to 40 times 1, or just 40. There are a couple of ways you can attack this last problem. Okay, you could think about this as having something that we can pull an I out of each time, because this is the square root of negative 1 times the square root of 24. I could think about this as like I times the square root of 24 times I times the square root of 3 times I times the square root of 2, and then multiply through. So this would make 1, 2, 3 i's. That's going to be I cubed. And then if we multiply these together, 24 times 3 is, 24 times 3 is 72, times 2 is 144, so we have the square root of 144 I cubed. We know that the square root of 144 is 12, and we know that the square root, I cubed is, let's go back and check it, negative I, or negative square root of negative 1. For the sake of this one, we're just going to call this negative I. Okay, so this becomes 12 times negative I. We're going to go ahead and put that negative out in front for a final answer of negative 12I is our answer after cleaning them up. Okay, So just a reminder, if you run into I squared or I to the fourth, you know you can turn those into -1 and +1 respectively. And then if there are any i's